Have you ever wondered what does a black hole looks like? What is the most convincing proof that black holes exist? Is it all just a theory? Well, all these questions will soon have their answers. Are you curious to know more about the black hole theory and how it might be proved soon in the future by the James Webb Space Telescope? Well, continue watching the video to enter the space of space. Welcome back to our channel, everyone. In today's video, we will talk about how the James Webb Telescope will prove Stephen Hawking's black hole theory right. Before we begin with the video, let us know a little bit more about the great man behind the black hole theory. Many people considered Stephen Hawking to be the smartest person on the planet, despite the fact that he never released his IQ score. When a New York Times reporter questioned Hawking about his IQ, he said, "I have no idea, people who boast about their IQ are losers," according to The Atlantic. Stephen Hawking was widely recognized as one of the world's greatest theoretical physicists. From the Big Bang to black holes, Hawking's work on the origins and structure of the universe revolutionized the discipline, and his best-selling books appealed to readers who may not have Hawking's scientific background. Hawking, who was 76 years old at the time of his death, died on March 14, 2018. So, now that we are familiar with the legendary physicist, let us finally begin the video. When talking about black holes, a blazing whirling ring of material with the black hole down the middle of the disk would be what we would expect to see, assuming our telescopes could zoom in far enough if we want to take a look at it. Astronomers have discovered a half-dozen or so binary star systems, two stars orbiting each other, in which one of the stars is invisible but must exist, because it exerts sufficient gravitational force on the other visible star to cause it to orbit around their common center of gravity. The mass of the invisible star is significantly greater than 3 to 5 solar masses. As a result, these invisible stars are regarded to be potential black holes. Supermassive black holes, approximately 1 billion solar masses, have also been discovered at the centers of numerous galaxies and quasars. But what is exactly the black hole theory? Stephen Hawking theorized those concentrated regions in the superhot, compact early universe could have formed the first black holes in the early 1970s. The formation of primordial black holes at the beginning of time is based on a basic fact: the universe's large-scale structure is the product of microscopic variations seconds after the Big Bang. According to this theory, pockets of these fluctuations would reach a critical density and be ready to collapse as black holes. Still, the extreme heat surrounding them would prevent them from collapsing instantly. Particles were so hot that they were zipping around like crazy, unable to collapse into black holes until the universe spread out and cooled enough to allow it, according to Gunther Hasinger, the European Space Agency's Director of Science. According to Hasinger, this collapse would occur only when elementary particles known as quarks are able to merge into protons, which would begin when the universe was only a fraction of a second old. According to Nico Capilouti, an astrophysicist at the University of Miami who led the study, the group set out to see if the universe we observe today could have been created with this new cosmology of primordial black holes. According to their concept, a universe with primordial black holes operating as the dark matter could resemble our own. Primordial black holes and dark matter are not mutually exclusive, says Learman. Primordial black holes are one possible form of dark matter. According to him, the sheer number of scientific puzzles that could be investigated with this single model is incredible, and the study's methodologies were rigorous. Now, what is dark matter? Are they the same as the black holes? No, they are not the same. Dark matter, which has never been directly detected, is assumed to make up the majority of matter in the universe, and serves as an unseen framework for galaxies to form and develop. Physicists have spent years putting hypothetical dark matter particles like sterile neutrinos, weakly interacting massive particles, WIMPs, and actions to the test. On the other hand, black holes have been observed. A black hole is a region of space where stuff is so densely packed that it produces extreme gravity. Its draw is so strong that not even light can withstand it. Most galaxies have black holes in their centers. So, how is stuff about the black holes and dark matter connected to the James Webb Space Telescope? More stars and galaxies would have developed around primordial black holes in the early universe, the time period covered by the James Webb Telescope, if dark matter is made up of them. But before we dive into all of that, let us get to know a bit about the James Webb Space Telescope. The $10 billion James Webb Space Telescope, NASA's largest and most powerful space science telescope, will explore the cosmos to learn about the universe's history, from the Big Bang to the birth of alien planets and beyond. It's one of NASA's great observatories, massive space telescopes like the Hubble Space Telescope that stare deep into the universe. The James Webb Telescope, which will look at signals from more than 13.5 billion years ago, could provide a link between Hawking's decades-old theory and dark matter. Researchers did not have a real sense of scale when Hawking hypothesized primordial black holes, Hassinger said. They assumed the black holes created would be very small, therefore, scientists searched for gamma rays, produced by minuscule black holes in the years that followed. Most researchers put the notion on hold for decades when they couldn't discover any. Scientists only realized afterward that primordial black holes might come in a variety of sizes, including much larger ones. According to Hassinger, the concept of primordial black holes acquired a lot of popularity after the first gravitational wave detections, which showed the presence of heavier black holes. According to Capilouti, even with today's greatest telescopes, scientists still have a big gap in their understanding of the early cosmos. Astronomers can only see the last 13 billion years of the universe's history. Still, it is estimated to be around 14 billion years old. He claims that the missing billion years are riddled with unanswered questions, such as how we came to have black holes billions of times the mass of the Sun. With today's knowledge of physics, the genesis of these supermassive black holes is difficult to explain. Hassinger is optimistic that the James Webb Telescope will detect stars in the deep field, a dark area of space where the Hubble Space Telescope discovered a slew of the oldest known galaxies for the first time. And if that happens, it will most likely happen within months of the observatory's opening. According to Capilouti, James Webb will open that window into a remote age of time. Suppose it discovers that protogalaxies are far more numerous than expected. In that case, their number and characteristics may indicate whether primordial black holes exist. However, Capilouti believes that the smoking gun will most likely be the finding of gravitational waves from a primordial black hole in the future. James Webb may test the author's hypothesis, according to Learman, which is an exciting possibility. This will not fully settle the question of whether dark matter is made of primordial black holes, he argues. Scientists rarely aim to prove their theories correct, instead, they come up with a hypothesis and try to shoot it down, according to Hassinger. The more times an attempt to debunk a hypothesis fails, the more solid it gets. The idea persists if it can't be refuted, at least until the next generation of experiments and discoveries. We'd be in trouble if scientists study the deepest Webb observations and don't see an inkling of a shift from the conventional model, Hassinger says. If you found this video helpful, make sure to like the video and subscribe to our channel for more such content. Share this video and click on the bell icon, so you get a notification whenever we upload. What did you think about this video? Let us know your thoughts in the comments below. For now, we have to part our ways, but do not worry because we will be back soon with another interesting video. Till then, stay safe and bye-bye.